All right, so today we are looking at what's the connection. So, how do things like graphs and tables and equations connect to each other? Writing a situation. Each representation below represents a different set of data. For each part, brainstorm a situation that could fit the data. Provide a title and labels for graph A. Identify the variables for the equation B. Provide a title and missing values for table C. So A is a graph, and we want to look at things like where is the y-intercept? So this is starting at $16,000. We can also see that the function is decreasing, and we can see down here that they've got years. So I might put here on the side value and have this be about money. And something that starts at $16,000 might be a new car. So this might be value of a new car. And it would make sense because each year the value of the new car is decreasing. By the time you get out here, 5, 6, 7, 8 years, you're looking at around $6,000. Like those are possible scenarios that would make sense. So this one, the situation might be value of a car. And I put that as my title also. You don't need to be super creative as long as it's accurate. All right, so B, we have something that has a starting value of $180. We have a multiplier that is over 1, meaning that it is something that is increasing in value. And it's increasing by 22%, which is pretty decent. So this is probably not money in an account. So maybe we would say something like the value of an antique. Maybe you bought the antique for $180 and then it's got a 22% increase. If that's the case, T would be number of years. And B of T might be the value of the antique after T years. Now, you didn't have to have the same example as me, just one possibility. By looking at the numbers and saying, what is something that's possible? What has a possible starting value of 180? What has a possible increase of 22%? A bank account just didn't make sense on that one. Now, on this last one, you can see I've already filled a bunch of the numbers in because they were so many digits long. But what we're saying is in 1980, we had something that was worth 226 million. And over here on the right side, they gave us that the multiplier was 1.02. So if we were going to do something like write an equation, 226 million would be our initial value. 1.02 is our multiplier raised to the x power because it's repeated multiplication. What is something that might start at 226 million and be increasing by 2%? I said population of a country. Also, you could think of things like the value of a property. You might find some sort of property that's very expensive and that over the course of time it increased in value. And then they asked us for this one, you can see that they've got up here 1 billion. And there were little lines on the sides for like, when does that happen? In what years do you get up to the 1 billion mark? Now, I would suggest after you've written the equation, typing it into your graphing calculator, and then you can scroll down through the table. And what you would find is that 1980 would be your 0th year. And by the time you get down to year 75 and 76, you're on either side of the 1 billion. And so if you add 75 years to 1980, you would be between 2055 and 2056. So the original question asked us to brainstorm a situation. So the first one might be value of a car. The second one might be value of an antique. The last one might be population of a country, but lots of options as well. All right, 878. A virus has invaded Letitia's favorite mountain fishing lake. Currently, there are an estimated 1,800 trout in the lake, and the Fish and Game Department has determined that the rate of fish deaths will be 1/3 of the population per week if left untreated. So if we started with the 1,800 up here, sketch a graph showing how many fish are left. Well, if we lose 1/3 of the population, that's the same as keeping 2/3. So you might do something like 1,800 times 2/3. And 2/3 of 1,800 is 1,200. So when you went over to 1, you might be at 1,200. And then you would just keep going and you would get sort of that downward curve. It's not going to touch the x-axis because Hypothetically, you are never going to run out of fish because you could go to decimals, but in the real world, eventually we will run out. So it says, theoretically, will trout ever completely disappear from the lake? We would say no. Y equals 0 is an asymptote. However, we know that eventually the number of fish will fall below 1, and you can't, at that point, reproduce. You can't count fractions and decimals of fish. So we would say no as like the hypothetical, but we know in reality we will eventually run out. All right, from graph to equation. Suppose the annual fees for attending a public university were $7,000 in 2010, and the annual cost increase is shown at the right. Write an equation to model the situation. So one of the strategies that we used was to take the y value and divide it by the previous y value, and that would give us our multiplier. And so it is 1.1. You could also do the amount of change divided by the previous, and that would give you just the 0.1 part of the answer. So when we go to write our equation, y equals initial value of 7,000, multiplier of 1.1 to the x. Use this model to predict the cost of attending a public university. In the first year, you would be eligible to enroll. Show work algebraically. So if we look at this and we say, you as 8th graders would be eligible to enroll. It is currently 2021. So you'd be eligible to enroll in 4 years. So that would be 2025. So if we wanted to do that, that would be how many years? 15 years later. So we would do y equals 7,000 times 1.1 to the 15th. And we would say that's approximately, no one is going to ask you to do this in your head, 1.1 to the 15th is 7,000 times 4.177. And it goes on. I'm actually going to leave it on my calculator screen to multiply by the 7,000 so I get a more accurate answer. Approximately 29,240.74. And I did have to round to the penny. And so that's going to be a dollar amount. What is the cost in 2000, assuming the rate of increase was the same during the first time period from 2000 to 2010? So this question is asking you to sort of work backwards and say, you know, if this pattern had developed earlier, if it had started earlier, and we go back to 2000, that was 10 years before this 0th term. So we would need to do 7,000 times 1.1 to the negative 10th. Your calculator can do that the same way, and you would get approximately $2,698.80. So 1.1 to the negative 10, you would type in 1.1, you would use the caret key to the, and I always put mine in parentheses, and I don't know that you have to, but I always do it to make sure that the negative 10 stays as a single number. And there is your 1.1 times to the negative 10th. And then I have to do times 7,000. Notice I leave it on the screen in order to do that to get the most accurate answer possible. All right. So if we go on to the back, using the model, what is the calculated cost for 2012? So the original model was the y equals 7,000 times 1.1 to the x. Year 0 was 2010. So 2012, we would just say 2 years have gone by, and that would be 8,470. Are you confident about this value? So what we're really asking you there is, like, does that seem reasonable? Does it seem reasonable that 2 years ago you would have been at 7,000 and now you're 8,470? It's probably not a good representation over this period of time. It seems like that's a pretty big 2-year increase. If you know anything about colleges, it's probably not reasonable. All right, to base, one single year jump and then continue to hold that true year after year after year seems possibly a little unreasonable. In 2012, the annual cost was actually $8,244, Why is it different from your answer? Well, that means that it's got a negative 226 for the residual, right? Our actual came in at 226, lower than our expected. It implies that fees are actually growing slower than 10% per year. So growing at a rate less than 10% per year. And the 10% was because 0.1, the 1.1 means growing because it's greater than 1. The 0.1 is your 10%. We didn't actually grow by 10%. So we would say growing at a rate less than 10% per year. All right, the next set, equation to graph. For each equation below, make a reasonable sketch of the graph without making a table first. So things we need a 5 as our initial value. So you can see that this little curve that's already there crossing the y-axis at 5, and that the multiplier is 3. So then we would have, 5 times 3 would be 15. And then times another 3 would be 45 right before here. And then we would just sort of estimate a curve. B, starting value of 10. So 10, 20, 30, 40, 50. 10 going to be right on that little line. And then 1/2, meaning half as high as the previous, half as much as the previous, half as much as the previous. Or if you're going in the other direction, double the previous, double the previous. And then we could draw our curve. Remember, our curve should not hit the x-axis. It should look like it's getting closer and closer. 1/10 is your intercept. So you can see this little curve that's already started, very small, and then times 5. So we're only at 1/2, and then we're up at 2.5, and we would continue this curve. So using the y-intercept and using the multiplier to generate the points on the graph instead of making a table. Situation, 100 gram sample of a radioactive isotope decays at a rate of 6% every week. How much of the sample will be left 1 year from now? So first of all, 100 gram sample means we're starting with y equals 100. If it's a decay, and that's really important, of 6%, that means that the sample is still keeping the other 94%. So 0.94 is our multiplier to the x. Exponential because it's always 94%, 94%, 94%, which would be repeated multiplication. And so we would say y equals 100 times 0.94. And if it's 1 year from now, but you can see that the decay rate is per week, that means we need to go with an exponent of 52 because it's 52 weeks, not 1 for 1 year. And I would keep this number on the graphing calculator screen because it is so long, and I'm sure the graphing calculator had to round because of space. So I would go with approximately, and it is approximately 4.005 grams. So make sure you're leaving that on the screen and then typing times 100, and that way your answer that you get here and that you choose to round here has only actually been rounded once. The Math Club is fast becoming one of the most popular clubs on campus because of the fabulous activities it sponsors annually for Pi Day on March 14th. Each year, the club's enrollment increases by 30%. If the club has 45 members this year, how many members should it expect to have 5 years from now? So our initial value of members is 45, referring to this year, increases by 30%, meaning an increase always starts with 1 point, and 30% would be 0.3. To the x, because it's percentages, it's repeated multiplication. If we want 5 years from now, that means that our x value is 5 because each year the enrollment increases by 30%, and we want to know 5 years from now, so that's an easy one. So y equals 45. I would do the 1.3 to the 5th, 3.71293, and the answer that you get has a decimal, and we have to round it to whole people. So approximately 167 members. All right, 2 questions left. Barbara made a bad investment. Rather than earning interest, her money is decreasing in value by 11% each week. After just 1 week, she is down to 142.40. How much money did she start with? If she does not withdraw her money, how long will it be before she has less than half the money she started with? So we are thinking about how do we get that starting value? And we've got to think about the multiplier. So we're going to think about y equals a. Our multiplier, if she's decreasing by 11%, is 0.89 to the x. And we have one coordinate after just 1 week, and it's decreasing each week. She's down to 142.40. So we can do 142.40 equals A times 0.89, and then X is to the first because it's after 1 week. That's really easy because that just means 0.89. So I would divide both sides by the 0.89 and get that the A value, the initial value, is 160. So I'm working with the equation y equals 160 times 0.89 to the x. If she does not withdraw her money, how long will it be before she has less than half of what she originally invested? So half is what? $71.20. So we want to know when will she be less than that number. I would grab my graphing calculator and I would put in, see if I can space this over so we can see, yay, 160 times 0.89 to the x. And then I don't actually need the graph. I hit graph to let it sort of process. It's not going to make a difference. I'm not going to get any graph because of where I'm not zoomed into correctly. Second table. And so I'm going to look at the table and look down here and say, okay, well, when x is 6, we're at 79.52. And we want to know when we are at less than half of what she originally invested. She originally invested 160. Oh, so I actually have to be under $80, not under 71.20, because the initial value was 160. And at 6 weeks, when x equals 6, y equals 79.52. So we would say after 6 weeks, she's just under the half of the original 160, half of which is 80. I'm hoping some of you caught that and you wanted to correct me, and then you realized I figured out my own mistake. Larry loves music. He bought $285 worth of music using his credit card, and now he cannot afford to pay off his debt. If the credit card company charges him 18% annual interest compounded monthly, how does Larry's debt grow as time passes? So he's being charged interest, which means it is increasing, which is not a good thing. How much would he owe for the original $285 at the end of the year if he made no payments to his credit card? So he is paying 18% annual interest compounded monthly. So the first thing I would need to do is find out what is a 12th of 18%, and that is 0.015. So each month he's getting charged 1.5%. So we would say y equals the original 285 increasing, so it starts with a 1. 0.015 was our monthly, so 1.015 is our increasing. X is per month, and we want to know if he didn't make any payments for the whole year. So we're actually going to substitute for X 12 months because it's compounded monthly. This one, you're going to want to leave the 1.015 to the 12th on your screen and then multiply it by the 285 in order to get a best estimate of 340.75. So he is going to actually need to pay the credit card company $340.75 at the end of 1 year if he doesn't make payments all year, when he could have just paid $285 if he hadn't put it on the credit card. So he's actually paying an extra $55.75 in interest. But if it was one of those things where maybe he needed it for work, maybe it was worth the extra fee in order to use that music for a year. Let's say he was doing YouTubing as his job and he needed to pay for music rights to have it on his video. Well, then maybe it was worth the $55 fee if he was then earning money using the music.